Hi friends, this is Syed Reshma Sharif. In this video lecture, I am going to discuss about a frequency domain sampling and reconstruction of discrete time signals. Okay, to analyze the discrete time signal, this discrete time signal is converted into an equivalent frequency domain represented by the frequency domain representation is known as Fourier transforms, which is represented as x into e power of j omega. Okay. To analyze this frequency domain, the representation is known as a frequency Fourier transforms, which is represented as x into e power j omega. Okay, but frequency domain representation is this only is not enough for convenient representation for discrete time signal. Okay, just only the frequency domain representation is not enough for a convenient representation of a discrete time signal. For convenient representation of discrete time signal, this frequency domain representation is not enough. Okay, then discrete time signal is represented as x of n. It is represented as x of n, whereas discrete time signals. Then Fourier transform is sampled to obtain a frequency domain sequence that is x of k. This Fourier transform is sampled to obtain x of k. This sequence is known as a discrete Fourier transforms. Okay, then this discrete Fourier transform is a powerful tool. This discrete Fourier transform is a powerful tool to perform frequency analysis. Okay, frequency analysis of discrete Fourier transform. Hence, we go with the discrete Fourier transform to perform the frequency analysis of a discrete time signal. Okay, in this topic, we will establish a relation between Fourier transform and discrete Fourier transform. Relation between Fourier transform and discrete Fourier transform. Okay, now let us consider a non-periodic discrete signal that which is represented as x of n. Okay, here x of n can be represented as x of e to the power of j omega. Okay, this now the Fourier transform of x of n can be represented as x of e to the power of j omega is equal to x of omega is equal to summation of n is equal to minus infinity to infinity x of n e to the power of minus j omega n. This is represented as equation 1. This is represented as equation 1. So, this is the Fourier transform representation of x of n. What was this? Fourier transform representation of x of n. Here, x of e to the power of j omega is a periodic with fundamental frequency. This is the periodic with fundamental frequency ranging from 0 to 2 pi. Okay, and the unit for this omega is radians. Okay, here the omega is a continuous function. This omega is a continuous function. This is the graphical representation of x of e to the power of j omega. Here omega will be in a x-axis, whereas y-axis there will be a continuous time signal. X of e to the power of j omega. There is a continuous signal that omega is ranging between 2 and 2 pi. This is a continuous time signal. Okay, this is 0. It is ranging from plus 2 pi to minus 2 pi. This is the graphical representation of x of e to the power of j omega. Now let us take n equidistant samples, that is 0 omega less than or equal to 2 pi. It ranging from 0 to 2 pi. So we will take a sample here. So we will take a sample. First sample. This is for first sample. This is for second sample. This is for third sample. Okay. If we start from 1, it take from 1 to n. We are starting from 0, so here it is of between n minus 1 samples. If we take from 1 the samples are n, but here we are taking from 0, the samples are n minus 1. Okay, this is the first sample. Now the width for each sample from here to here and from here to here, the distance between those samples are delta omega. Okay, the distance between each sample is represented as delta omega. Then this delta omega is equal to 2 pi by n. Okay, we are taking sample space as 2 pi by n because the range is up to 2 pi. Here we are taking n number of samples, so we are taking samples as a 2 pi by n for n number of samples. Okay. Using this analysis in equation 1, we will replace omega. Here in this equation, we are replacing with omega as 2 pi by n. What we will get? We are replacing this equation 1 with delta omega is equal to 2 pi by n into k. Whereas here we are taking omega is equal to 2 pi by n into k. Then k is nothing but it is a range in between 0 to n minus 1. Okay. So here if we take k is equal to 0, then automatically omega is equal to 0. If we take k is equal to 1, then equation will be 2 pi by n. Here this will be represented at samples at 0. It will represent samples at 0. Okay. Whereas k is equal to 1, samples at 1. Whereas k is equal to 2, the sample at here 4 pi by n up to n minus 1. It will be represented as n minus 1 samples. These are the individual samples. Okay. If we replace omega is equal to 2 pi by n into k in equation 1, replacing this omega in equation 1. Okay. Then what we will get? X of 2 pi by n into k is equal to summation of n is equal to minus infinity to infinity x of n e to the power of minus j 2 pi by n into kn, where k ranges from 0 to n minus 1. Okay, let this one will be in equation 2. After substituting omega is equal to 2 pi by n into k in this equation. Okay, this will be in equation 2. If you observe the equation, this term represents a summation from this total term represented the summation from minus infinity to infinity. Okay, minus infinity to infinity. If may have infinity number of summations. Okay, it may have an infinity number of summations. If we expand this above equation, and we can write this equation as x of 2 pi by n into k is equal to summation of n is equal to 0 to n minus 1 x of n e to the power of minus j 2 pi by n to k. Here for x is equal to 2 pi by n into k, for we know that x of n having an infinite number of summations for n samples. Then for n is equal to 0 to n minus 1 x of n e to the power of j 2 pi by n into k. For n is equal to n minus 1 samples, we will get the summation for this. We need to add n samples. Okay, after we get what we will get for n is equal to n, for this we have to add n samples, that is to n minus 1. Okay, and the summation before this summation will be a summation of, for next summation will be adding. For previous summation we have to subtract the summation. What we will get?